Tutorial number 6 explains the content and handling of the Event History Calendar, or EHC, which is part of the survey variables for anchor respondents. What is the EHC? EHC stands for Event History Calendar. This special module was introduced in Wave 2 to collect episodes of partnerships, children, residents, the household grid, education, and occupation status between waves. Episodes are marked on an axis per mouse click, an easy way to collect monthly information. Warnings appear for significant inconsistencies, which can then be corrected. Only applicable categories are shown, for example partners previously mentioned by the anchor respondent. Furthermore, data from previous waves is preloaded into the calendar, an approach called dependent interviewing. Respondents can then retrospectively fill in information for the months between the last and the current interview, together with the interviewer. But what exactly does the EHC look like? Here we have an example. The interviewer sees this screen during the anchor interview. A short introduction and the question text, in German, are shown at the top of the screen. This particular part of the EHC is focused on partnerships, asking the respondent to mention all romantic partners they had since the last interview. Information from any partners reported in the previous interview is already listed as a preload. The name of the partner reported in the previous wave was Hans-Peter, male. The interviewer then enters any new partners reported in the current wave on the following lines. In this example, the anchor respondent has a new male partner, Robert. The next slide shows the time axis. In this example, the last interview took place in October 2008. Each month up until the month of the current interview, June 2009, is listed on the axis. The top section summarizes relationship, cohabitation, and marital status with Hans-Peter, the partner from the previous wave. All 3 boxes are checked, indicating that at the time of the last interview, the respondent was in a relationship with Hans-Peter, they lived together, and they were married. This is the preloaded information. The next section concerns the respondent's new partnership with Robert. The same 3 rows of information are shown, but as of now they are empty. Together with the interviewer, the respondent can now fill in the relevant information for both partners. In this example, the anchor respondent checked each row and marked up until which month the relationship, cohabitation and marriage lasted with Hans-Peter on the axis. We can see that Hans-Peter moved out in January 2009. 1 month later, the relationship ended. However, they are still married, which is plausible as the divorce process can be lengthy. Next, all episodes that apply to the new partner Robert are marked. The new relationship with Robert began in May 2009 and continues to the time of the interview. In another example, the respondent has recorded implausible entries. The marriage with Hans-Peter ended in February 2009. However, the respondent also recorded a marriage with Robert that began in December 2008, indicating 2 parallel marriages. In Germany, only 1 marriage is legally binding. In this case, a warning appears, indicating an inadmissible overlap in marital episodes. At this point, the interviewer prompts the respondent to change 1 or both entries. How is the data from the EHC stored? Monthly variables are created for each type of episode. In the case of partnerships, this includes partnership, cohabitation, and marital episodes. The variable EHC2P1, for example, stores the current relationship status with partner 1 at the time of the interview. In waves 3 to 13, the variable EHC2 P1 M32 stores the anchor respondent's relationship status in the month of the current interview. From there, information is stored via backward progression up to the month of the previous interview. The variable EHCID marks the month of the previous interview. Data users often ask why month 1 contains missing values, assuming that month 1 represents the month of the previous interview. After listening to this tutorial and/or reading the available pairfam documentation, you will correctly understand how the information from the EHC is stored. Let's illustrate this with an example. The current interview took place in February 2013, and the previous interview was in January 2012. Therefore, February 2013 represents month 32, January 2013 month 31, and so on. The month of the previous interview would then be month 19. If this hypothetical anchor respondent was in a relationship with partner 1 from the previous interview up until the current interview, months 19 to 32 would be assigned the value 1 in a relationship with partner 1. But what about months 1 to 18? As the EHC only collects information between the two interviews, months 1 to 18 are assigned the missing value -3, does not apply. Assuming the respondent participated in the previous wave, information from before January 2012 is stored as part of the previous interview. Why 32 months? Per design, more than 32 months between two interviews should not be possible, as anchor respondents may skip only one wave of the survey in a row before being excluded from the contact pool. Therefore, even if the respondent did skip one wave, there would only be approximately 24 months between interviews. In a few cases, the period between interviews after leaving the panel for one wave can be longer. For example, a respondent could hypothetically be interviewed in the first wave in October and again in the third wave in April, resulting in a total of 31 months available to fill in up to month 1. Thus far, no entries have been recorded for month 1, generating a complete set of missing values for this time frame. Please be aware that in wave 2, the maximum number of months in the event history calendar is 18, not 32. Therefore, the anchor respondent's relationship status in the month of the interview in wave 2 is stored in the variable EHC2 P1 M18. This marks the end of the 6th tutorial. The next tutorial will focus on further variable types and their order of appearance in the anchor datasets.